welcome back to our channel Nursery to Varsity. In the previous tutorial, we have learned the theory and the concept of the while loop, and now it's time to code. In this tutorial, we will going to understand 3 frequently asked questions using while loop. Question 1, write a program to find the sum of all the even numbers between 1 to n. Question 2, write a program to enter a number and print its reverse. In question 3, write a program to check whether a number is Armstrong or not. So let's start with our first question. Write a program to find the sum of all even numbers between 1 to n. That means say if n is equal to 5. Then even number up to 5 are 2 and 4. So the output of our program, it would be equal to 6. 2 plus 4 is equal to 6. Now let's think how would we find the sum. First we will take the input from the user and store this input in variable say n. Then we will initialize the another variable say sum which is equal to 0. Initially we don't know the sum, so we are initializing it with 0. Now as we need to find first even number and it starts from 2. So let's initialize I is equal to 2. And after that we need to iterate our loop from 2 to n would be whatever the input from the user. And inside the while body we will add sum repeatedly. That means in sum we will add sum plus I. This will be written inside the while loop. And after the end of the loop we will print it. So this is the simple logic to find the sum of even numbers. And if we need to find the odd numbers, then we will just replace 2 by 1 and we will iterate our loop by 2. Every time we will iterate it by 2. Okay, so that we get all the even numbers sum. So let's start coding. We will start with the libraries hash include stdio.h, then int main. We need the variable I, n and sum. So int I, comma n, comma sum. Let's initialize here only sum is equal to 0 and what we have learned that I is equal to 2. Now let's take input from the user, printf, enter a number, scanf, %d, %n. Now we are going to apply while loop. The condition up to which we need to iterate, that is we need to iterate I is less than equal to n, because we have to find the sum of all numbers between 1 to n. So we will include n. In the while loop we will add the sum as sum is equal to sum plus I and iterate our variable I is equal to I plus 2. This iteration gives us always the even number starting from 2. And if we write 1 over here and then we will iterate by 2, then it will be calculating all the odd numbers. There is a little difference only. And after completing the while loop, we will print the sum. That is sum of all even number between 1 to %d. We don't know what is n here, so we are asking %. So we are using format specifier which is equal to %d, and at first position we are writing the format specifier as n and then sum. Okay, return 0. And by this we have completed our program. So let's build and execute it. Here it is asking enter a number. So we have entered say 10. The sum of all numbers between 1 to 10 is equal to 30. See, we can recheck our answer by the even number between 1 to 10 are 2, 4, 6, 8, and if we include 10 too, because we are using it, so 10. And the sum of 2 plus 4 plus 6 plus 8 plus 10 comes out as 30. So our answer is correct. So now let's move to our next program. First let me close it. Moving to our next program, write a program to enter a number and print its reverse. In this program, if we input a number, say 1546, then our output will be reverse of this, that is equal to 6451, which is the reverse of the number. Manually, we can do this very easily with our basic understanding of the knowledge that we just have to write our number in the opposite order. But in coding, there is a different logic. So let's discuss that logic. First, we input a number from the user and store it in a variable, say n. And now declare and initialize the another variable to store the reverse of a number. So we will going to use, say, reverse, which is equal to 0. To print the reverse number, we need the last digit. So we will extract it by performing modulo division. Modulo division is nothing else but, say, digit is equal to whatever will be the number modulus 10. And this will give us the last digit. We will add this number in the reverse and increase the place value of reverse by 1. That means to multiply reverse by 10. That means in mathematical formula, I can say reverse is equal to reverse into 10 plus this digit, last digit. And as we have processed this last digit, so we need to remove this last digit from our number and we will update our number n is equal to n divided by 10. And this operation will remove the last digit, and again we will perform the same set of statements these until n is not equal to 0. We have to repeat the steps until n is not equal to 0 or n is greater than 0. So this is the logic of our program, and now we need to code this. Okay, hash include stdio.h int main. Now we need two variables, int n, which we take from user, and reverse, which is we will initialize it from 0 here only. Okay, now we will take the input from the user by using printf, enter a number, scanf, %d, ampersand n. Now we have to apply loop over here. So we are using while loop. So while. Now what would be the condition? I have already told you that n, we will continue our loop until n is not equal to 0. Now what we have learned, that we need to increase the place value of the reverse and add the last digit to the reverse. So that means reverse is equal to reverse into 10. We are increasing the place value of reverse by 1 and adding the last digit. And last digit is what? Nothing else n modulus 10, which we have already learned. And now we have processed this last digit, so we have to remove this last digit by performing n is equal to n divided by 10. And this will iterate this loop until n is not equal to 0. We can also write over here n is greater than 0. Both works same. And at the end we will print our reverse number. Reverse is equal to %d reverse. Return 0. And here we go. So let's quickly build and run it. Okay, I forget to write over here a bracket. Now let's build and run it. Enter a number. So randomly I am entering 3672. So what will be the reverse? 2763. And the answer is correct. 3672 and the reverse is 2763. So let's close it. And now we will move to the last question of this tutorial. Write a program to check whether a number is Armstrong or not. Now you are thinking that what is an Armstrong number? To solve this question, we first should know about the Armstrong number. An Armstrong number is an n-digit number that is equal to the sum of the nth power of its digit. For example, 371. It is an Armstrong number. Now the question is how? 371 basically it is a 3-digit number. And we are saying that Armstrong number is equal to the sum of the nth power of its digits. So 3 plus 7 plus 1 The result would be nothing else but 371. And it gives the same number which what we have. And that's why it is an Armstrong number. Now you have understand that what is an Armstrong number? That the sum of the nth power of its digits. The number of digits in this number is 3. So we are using this power of 3 in each digit and we are simply adding it, which will give the same number. So this is the concept of an Armstrong number. Now we need to see how we can build the logic of this program. First, we will take the input from the user and store it in a variable, say n. Now we will also make a temporary copy of this variable because at the end we need to compare our original number and the resultant number. So let's that variable be temp, which is nothing but it is equal to n. Because we are updating n at each loop, so it will be changed and we need to compare this number with our resultant number. Now we need to count the digits of a number. For that, we can use the simple mathematics trick of the log. If you don't know about logarithm, don't worry. We are just using a simple logarithm term here. For example, in the above number 371, if we take the log to the base 10 of this number, it will give us something 2 point something value. And we don't need the fractional value, so we will use the int of log 10, and then we will, because it is giving 2 point something, so we need to add 1, and which will give 3. And by this way we will count the digit of a number. After that we will initialize our resultant number, say because we need an Armstrong number, so variable would be as, and we will initialize it as 0. Now after initialization, in the loop the condition should be n should be greater than 0. And why it is so? Again, we need to find the power of nth digit in a number. So we need a math function called power function. It is nothing else but POW, power function. It is defined in the math library. So we have to add this library too in our program. We just need to find the last digit and multiply it digit times. That is the number of digits in a number. So first we will calculate again the same as last digit, which is nothing but n modulus 10, and then we have to add the as, as is equal to, there is a shortage of space, so let me write over here, as is equal to as plus, we are going to use power function. Power function takes two arguments, first the digit and the second how many times we need to multiply that digit. We are using the last digit d, comma, and this value, which is nothing else, say it is a digit. This is the counting of the digits in a number. So let's say we are writing over here digit. Don't worry if you are unable to understand about the function. We will cover them in our upcoming tutorial. Until then, you just understand that function is a set of statements which is used to perform the same calculation many times whenever needed. So we are using over here power function. It will give us what we want. For example, 3 cube. So it will take the last digit in the 371. The last digit is 1 and the digit is counting as 3. So 1 cube. It will find us as 1 cube, which is nothing as 1. And after processing this last digit, we need to remove this. So we will dividing 371 by 10. It will give 37, and now again we have to apply these steps, and this time we have the last digit at 7, and the power of this 7 by 3 is nothing else but 343. Okay, and then again we will divide this 37 by 10 and we get 3, and here the last digit is 3, so the power function will calculate as 3 cube, and this will be adding again 1 plus 343. Because we are adding it again and again in the loop here. Now 3 cube is nothing else 27, and after adding these 3 we get 371, and by this way our loop will work. Now whatever will be the result, this as will come, we need to compare it with our original number. If both comes out to be equal, then we can say that the number is Armstrong, otherwise it is not. I hope so you have acquired sufficient knowledge. So we can code now. So let's start coding. We need two libraries this time. Hash include stdio.h and hash include math.h, because we are going to use power function and round function in our program. Int main Now we need different variables, say int n, which will be the input from the user. A temporary variable, say temp, for comparison with the real value. Last digit, say digit. Always make your variable names meaningful. Okay, and digit, which will count how many digits in your number, and AS, Armstrong number. So first take the input from the user, printf, enter a number, scanf, %d, %n. Now we will initialize our AS as equal to 0. We can initialize here too, so let's initialize here only. And in temp we are using n. Temp is equal to n. We are copying our number. Now we have to calculate the sum number of the digit in our number. And we have already discussed the logarithmic path, that we are going to use log10, and then also we need integer variable, and in that we need int data type, because log always give a fractional value or a float value. So we need to find log10, say temporary variable, and +1. Why? Because it gives a value less than 1. So we have to add +1 in this. Now we are using the loop. In loop, we have already discussed, we are going to use the condition that n should be greater than 0, up to which we have to iterate. And in our loop, what we have to add, AS is equal to AS plus, we are using round function and again a power function. We have discussed the power function. It takes two input. First the last digit, which is nothing else but temp modulus 10, and second the digit, or we can say the count variable, how many times we have to multiply that digit. In this we are using two math functions, round and power. Round functions rounds a fractional number to the nearest integer. So whatever the power value will give us, it will convert our value into the integer. So that's why using round function and power function, it is used to find the power of any number. And at the end we are going to reduce our temporary variable as temp divided by 10. This is the end of the loop, and after the end of the loop we will compare both the numbers, that is the AS Armstrong number and the original number. We will ask if n is equal to AS, then what will be the output? Printf %d is an Armstrong number, comma n. Else, if it is not so, then we will print %d is not an Armstrong number. Okay, and at the end return 0. And that's it. We have completed our program. I've seen a mistake over here. We are using n while we have to write temp, because we are changing temp inside the loop. If we writing n over here, then it will go infinite, because it will never decrease and it will never become less than 0, so the loop will never end. Okay, so this is the mistake I have realized. Now, so let's build and execute it. Enter a number, because we know 371, so let's check that only, and see 371 is an Armstrong number. Now let's check another one which is not an Armstrong number, so randomly say 234. 234 is not an Armstrong number. We are getting the correct result, and that's all for today's tutorial. In the next tutorial, we will see some more questions using while loop only. Hope you have enjoyed this tutorial, and if you have found any queries, you can either comment in the comment box or mail us at nerd2ware@gmail.com. Do follow our channel Nursery to Varsity on all our social media handles. Keep liking, keep subscribing, and do not forget to press the bell icon. Thanks for watching. Stay tuned.